Hello, my dear Prep 1 students. Hope you're all fine today. In today's video, we are going to complete the second part of multiplying binomials. So, I would like you all to have your binders beside you, page 22, and let's go and solve question number 3. Before going and solve question number 3, we would like to remember what are the special cases that we have studied. We said that if I have a plus b all squared, to find the answer here, I'm going to make a squared plus b squared, and I'm going to make 2 times a times b. So it's going to be positive 2ab. And if I have a minus b all squared, I'm going to find the first squared, a squared, the second squared, which is b squared, and then 2 times the first times the second, which is going to be 2ab. And here I will have a negative sign. According to the sign given between the bracket, here I have a positive, so the second term was positive. Here I have a negative, so the second term was negative. And the last case we're going to study today is when I have two binomials, for example, a minus b multiplied by a plus b. Here we have two binomials and both of them are exactly the same except for the sign between the two terms. So, in this case, the rule I'm going to follow is that I'm going to make the first term squared, the second term squared, and I will have a minus sign between them. So for example here, if I'm having 3x minus 4 multiplied by 3x plus 4. We have here two binomials and they are the same. The only differ is the sign between of the two terms. One is positive and one is negative. So here we are going to apply this rule. How are we going to apply it? We are going to take the first and square it. 3x, so the answer is going to be 9x squared. Because we know that 3x, if we want to square it, this is equal to 3 squared times x squared. So it's equal to 9x squared. Because simply 3x squared means 3x times 3x. Going and multiplying the coefficient, 3 times 3, this is going to equal 9, and x times x, both of them are the same variables. So I'm going to add the powers, 1 plus 1, so x is squared. And the same I'm going to do for the second term as well. Here my second term is 4. So I'm going to make 4 squared, which is going to be 16. And we said that I always have a negative sign here between them when I have two binomials multiplied together. They are the same, but they differ in the sign between them. So here I'm going to have 9x squared minus 16. Let's go now and solve more example in question number 3. 3x squared minus 5y squared times 3x squared plus 5y squared. By having a closer look, we will find that both binomials are the same, but the sign between them, one is positive and one is negative. So here we are going to apply the third case. How are we going to apply this case? We are going to take the first term and square it. This means 3 squared, which is equal to 9, and x squared, which is equal to x to the power of 4. And then we are going to take the second term and square it. 5 squared, this is equal to 25. And y squared, this is equal to y to the power of 4. And we said that when we have two binomials, exactly the same, except for the sign between of the two terms, all what we do is that we're going to put between the two terms a negative sign. Let's go now and go for number 2. m plus 6n multiplied by m minus 6n. Again, I'm having here two binomials. Both of them are the same. except for the sign or the operation between of the two terms. So we are going again to apply the third case, which is I'm going to make the first squared, which is m, so m squared is m squared, and I'm going to take the second and square it. 6 squared is equal to 36, and n squared is equal to n squared. And we said before that when I have two binomials multiplied together, they are the same except for the sign between the two terms, so I'm going here to have a negative sign. So let's go now for question number 3, and here we have half x minus 1/3 y multiplied by half x plus 1/3 y. Again, we have two binomials. All the difference between them is the sign between the two terms, or the operation between the two terms. And here we have fractions. We are going to perform the same steps. Either we have whole numbers or we have fractions. So we are going to take the first square, which is half x. So I'm going to make half squared times x squared, and then I want to have 1/3 y squared. So I want to have 1/3 the square of it and y squared. And of course we said that when I have two binomials and the only difference between them is the sign between them, so here I'm going to have a negative sign. If you wrote in your calculator half squared, this is going to give you 1/4. So half squared is equal to 1/4, and the x squared of course will remain as it is, minus, and 1/3, if you write it on your calculator, 1/3 squared is equal to 1/9, and for y squared it's going to remain as it is. I would like you now to pause the video, go and start solving question number 4 by yourself, and then come back to compare your answers with mine. So here again we are going to make, we have two binomials. The only difference between them is the sign or the operation between the two terms. Of course here we have 3y plus 2x, and we know that addition is commutative property, so it is the same as 2x plus 3y. There is no difference between them. So as we said, when I have two binomials having only the difference between them, the sign between them or the operation between the two terms, so I'm going to take the first square, which is going to be 4x squared, and the second squared, which is going to be 9y squared. And here I will have a negative sign between them. And let's go now to page 23, question number 4. Find the following products. Here I have a binomial multiplied by a trinomial. Let's first remember when I have, for example, 2x plus 4 multiplied by x minus 5, what I used to do is that I'm going to multiply the first term by the first and the first term by the second, and then multiply the second term by the first and the second term by the second. The same we are going to do here, but we are going to take each term in the first binomial and multiply it by each term in the second. So I'm going to multiply x squared by x to the power of 4, and this is going to give me x to the power of 6. And then x to the power of 2, I'm going to multiply it by x squared y squared. X squared times x squared, this is equal to x to the power of 4. And since I have here only y squared and there is no y squared here, so y squared will remain as it is. And I'm going again to multiply x squared by y to the power of 4. Both of them are different, so they are going to remain as they are. After we finished multiplying the first term by all the three terms in the second trinomial, so now we are going to go and multiply the second term, which is negative y squared, and please don't forget the negative because we lose marks in this lesson, especially for the signs. So we are going here to multiply negative y squared by each term alone. So negative y squared times x to the power of 4, two different variables, so they are going to remain as they are. It is negative x to the power of 4, y to the power of 2. And then I'm going to multiply negative y squared by x squared y squared. And this is going to equal, let me first erase this. And this is going to equal to negative. Here I have the x squared and no x's here. So x squared is going to remain as it is. And y to the power of 2 times y to the power of 2, this is equal to y to the power of 4. The last thing, I'm going to multiply now negative y squared by y to the power of 4. Again, same variables, so when I have same variables, I go and add the powers when I am multiplying. So it is going to be negative y to the power of 6. After we have finished, let's go and see if we have like terms or not. So by looking here, we will find that I have x to the power of 4, y to the power of 2, negative x to the power of 4, y to the power of 2. Both of them are like terms and both of them are the additive inverse of each other, so they are going to be cancelled. And then we are going to have positive x squared y to the power of 4, negative x squared y to the power of 4. And again, both of them are the additive inverse of each other, so they are going to be cancelled. All what I have now is x to the power of 6 and negative y to the power of 6. So my final answer after simplification is x to the power of 2, negative y to the power of 6. Before we go on completing question number 4, we would like to remember some important things. We have two operations, adding and subtracting, and multiplying and dividing. So when I am adding and subtracting, I am only doing this for like terms. So for example, if I have 2xy plus 5xy plus 2x squared y. All what I should do here to add the like terms, I'm going to go and look for what term have the same variable with the same power. So here I'm going to find that 2xy is the same as 5xy. Both of them has a variable x to the power of 1 and y to the power of 1. So I'm going to add those two terms and have a result of 7xy. Again, when I am adding and when I am subtracting like terms, I add and subtract only like terms. And when I am adding and subtracting, I only go and add or subtract the coefficient, and for the variable it remains as it is. It's a little bit different when I am multiplying or dividing. When I am multiplying or dividing, either I leave the power the same, or I go and add powers or subtract powers. So for example here, when I am multiplying 3 x to the power of 5 times 2 x to the power of 2, here I am performing a multiplication operation. When I am performing multiplication, I add powers. I go and multiply the coefficient, 3 times 2, and this is equal to 6. And for the variables, I go and add their powers. So here I will have x to the power of 5 plus 2, so it is equal to 6x to the power of 7. Please don't get confused between adding and subtracting and multiplying and dividing. In adding and subtracting, the variables remains as they are. They do not get changed. So let's go now and see question number 2. Question number 2, I have a squared minus 3b squared, and I want to multiply it with a trinomial, which is 3a to the power of 4 minus 2a squared b squared plus 5b to the power of 4. So again, I'm going to multiply each term here by the 3 terms in the trinomial. Let's begin first with a squared and multiply it by 3a to the power of 4. And again, when I am multiplying, I go and multiply coefficient. Here I don't have a coefficient, so it is 1. And remember, any variable without a coefficient before it, this means that my coefficient is 1. So 1 times 3, this is equal to 3. And a squared times a to the power of 4, again, if I have a squared times a to the power of 4, I am multiplying here. So I go and add the powers. I will have here a squared plus a to the power of 2 plus 4, which is equal to a to the power of 6. So here I will have 3a to the power of 6. Then I'm going to multiply a squared by the second term. A times negative 2a squared b squared. And again, please take care of the signs, especially when there is a negative sign. So I know here that for a squared I have a coefficient of 1. So 1 times negative 2, this is equal to negative 2. And a squared times a squared, again multiplying the same variable means that I'm going to add powers. So it's going to be a to the power of 4. And when I have here b to the power of 2, and there is no b here, so b to the power of 2 is going to remain as it is. And then go and multiply a to the power of 2 by positive 5b to the power of 4. 1 times 5, this is equals to positive 5. And a to the power of 2 and b to the power of 4, here both of them are different variables, so they are going to be as they are, a squared and b to the power of 4. After we finished multiplying the first term by all the terms in the trinomial, now I am going to multiply negative 3b, and again please don't forget this negative 3b squared by 3a to the power of 4. This is going to give me negative 9a to the power of 4 b to the power of 2. And then I'm going to multiply negative 3b squared by negative 2a squared b squared. Negative times negative, so I'm going to have positive. And 3 times 2, this is 6. A squared, I have nothing. I have no variable here a, so a squared is going to remain as it is. And for b, I have here b to the power of 2 times b to the power of 2, which is equal to b to the power of 4. The last thing, I'm going to multiply negative 3b squared by positive 5b to the power of 4. Negative times positive, so my answer is going to be negative. 3 times 5 is 15, and b to the power of 2 times b to the power of 4, this is b to the power of 6, because I add powers when I am multiplying the same variables. After we finished until here, now we are going to do simplification. What is the meaning of simplification? Or put it in the simplest form, this means that I am going to combine all the like terms. As we can see here, I have only a term having a to the power of 6, so I'm going to write it as it is, 3a to the power of 6. And let's go now and see. I have here negative 2 a to the power of 4 b to the power of 2, and negative 9 a to the power of 4 b to the power of 2. So negative 2 plus negative 9, this is equals to negative 11. And the variables, when I'm adding or subtracting, remains as they are. And then I'm going to go and see, I will find that I have positive 5 a to the power of 2 b to the power of 4 and positive 6 a to the power of 2 b to the power of 4. Again, I am adding like terms. When I am adding like terms, I go and add the coefficient 5 plus 6, and this is equals to positive 11. And the variables, when I am adding like terms, they are as they are, no changes. And at the end, I have still negative 15 b to the power of 6. I would like you now, prep 1, to go and pause the video, answer question 3 and question 4, and come back to compare your answers with mine. I have here a trinomial 2a plus a squared minus 5 multiplied by a binomial 2a squared minus 1. So again, we are going to take each term and multiply it. So 2a times 2a squared, this is equal to 4a to the power of 3. Again, since I'm multiplying 2a times 2a to the power of 2, and the operation is multiplication, I go and multiply the coefficient, which is 2 times 2 equals 4. And if I have same variables, I add the powers. So here I have a to the power of 1 and a to the power of 2. So a to the power of 1 plus 2, which is a to the power of 3. And now I'm going to multiply 2a by negative 1. And please again, don't forget this negative sign. So 2a times negative 1, we know that anything multiplied by 1 is the same. So it's going to be negative, and don't forget the negative, and 2a. We have finished now multiplying the first term by each term in the other bracket. So we are going now to multiply the second term, which is a to the power of 2, by each one in the bracket. A to the power of 2 times a to the power of 2. So here I know that a to the power of 2 has a coefficient of 1, and I don't write the coefficient of 1. So 1 times 2, this is equal to 2. So positive 2. And a to the power of 2 times a to the power of 2, this is equal to a to the power of 4. Then I'm going to multiply a squared by negative 1. Again, please don't forget the negative sign. So a squared times negative 1, this is equal to negative a squared. Finished multiplying the second one by all the terms in the next expression. So now I'm going to multiply negative 5 by 2a to the power of 2. Negative 5 times 2a to the power of 2, this is equal to negative 10 a squared. And then I'm going to multiply negative 5 by negative 1, and this is equal to positive 5. After I have finished my multiplication, now it's time to go and see if I have two variables that I can add together, and they are like terms. I will have here negative a squared and negative 10a squared. Again, if I have here negative a squared and negative 10a squared, here I am performing adding and subtracting of like terms, because both of them have a to the power of 2, and the operation between them is either addition or subtraction. So when I am adding like terms, I will go and my variable will remain as it is and add the coefficients. I have here negative 1, negative 10, and this is equal to negative 11. So here my final answer is 4 a to the power of 3, negative 2a, positive a to the power of 4, positive 2a to the power of 4, negative 11, a to the power of 2, positive 5. And let's go now for question number 4. Again, I'm going to multiply each term by the other term in the other expression. So 4 times 2, this is equal to 8. 4 times negative a, and please again don't forget the negative sign. We usually lose marks for the negative sign. This is going to be equal to negative 4a. And now, after I finished multiplying 4 by all the terms in the second expression, now I'm going to take the second term, which is positive 2a, and multiply it by 2. Positive 2a times 2, this is equal to positive 4a. And then take positive 2a and multiply it by negative a, and again don't forget the negative sign. So this is going to be equal to negative 2a squared. And then I'm going to have positive 3a squared and multiply it by 2, and this is equal to positive 6a squared. And going to have positive 3a squared and multiplied by negative a, and again don't forget the negative sign, so this is going to be negative 3a to the power of 3. After I have finished multiplication and wrote my expression, we always go and check for like terms. So I'm going here to find that I have negative 4a, positive 4a. Both of them are the additive inverse of each other, so they are cancelled together. And I have negative 2a squared plus 6a squared, and this is going to be equal to 4a squared. Again, let's remember, when I have negative 2a squared plus 6a squared, here I am performing addition. When I am performing addition, the result, the variable will remain as it is, and I am only going to add the coefficients. So negative 2 plus 6, this is equal to positive 4. So here I will have the 8 is as it is, and when I added those two terms together, I have now positive 4a squared, and for negative 3a to the power of 3, there is no like term, so it's going to remain as it is, negative 3a to the power of 3. Hope it's a little bit clear now, prep 1. Let's go now for question number 5. In question number 5, I have x plus 4 all squared multiplied by 3x plus 2. Let's first go and remember together. We said that when I have a binomial and it's all squared, to find the result of this, I'm going to take the first squared, which is going to be x squared, the second squared, which is going to be positive 16, and 2 times x times 4. First, let's go and multiply the numbers. 2 times 4, this is equal to 8. And x is going to remain as it is. 2 times 4 times x, this is equal to 8x. So now I know that x plus 4 all squared is equal to x squared plus 8x plus 16. Now I'm going to take x squared plus 8x plus 16, and I'm going to multiply it by 3x plus 2. Again, I'm going to multiply each term by the term in the other expression. So now I'm going to multiply x squared by 3x. And let's remember that we said when I have x squared and I want to multiply it by 3x, here I am performing multiplication. So I am going to add powers. So the first step I should make is go and multiply the coefficient. So 3 times 1, this is equal to 3. And for the variables, since I have like variables or same variables, so I'm going to add the powers 2 plus 1. So this is equal to 3x to the power of 3. So my answer here is 3x to the power of 3. And then I'm going now to multiply x squared by positive 2. X squared times positive 2, this is equal to positive 2x squared. Let's go now and multiply the second term, which is positive 8x. Positive 8x multiplied by 3x, this is equal to, go and multiply the coefficient, 3 times 8, this is equal to positive 24. And x times x, this is x squared. Now, let's go and multiply 8x by positive 2. 8x by positive 2, this is equal to positive 16x. The last thing is that we're going to multiply the third term by 3x. 16 times 3x, and this is equals to positive 48x. And 16x times positive 2, and this is equal to positive 32. After I wrote my expression and found the result of multiplication, I will go now to search for like terms. So, by looking here, I will find that I have positive 2x squared and positive 24x squared. Both of them have the same variable of x to the power of 2. So, positive 2 plus positive 24, this is equals to positive 26. So I have here positive 26, and what about the variable? Again, when I am adding For example, here I have 2x to the power of 2 plus 24x to the power of 2. I am adding like terms. So when I'm adding like terms, I will go and add my coefficient. 2 plus 24, this is equal to 26. And my variables, since both of them are x squared, they are going to remain as they are as x squared. We only add powers when we are multiplying. So here this is going to be 26x squared. And going now to see if I have any other like terms or not, I will find that I have positive 16x and positive 48x. Positive 16x and positive 48x, this is equals to positive 64x. Again, since I'm only adding like terms, I add only the coefficient and the variables remain as they are. And at the end, I will find that I have 3x to the power of 3, and there is no like term, and positive 32, which is an absolute term. So they are going to be written as they are. Positive 3x to the power of 3, positive 32. And let's go now for number 6, and I need you to have your attention, please. First of all, I would like to ask you, what is the meaning of if I told you x to the power of 3? This means that I have x times x times x. So I can say that I have x to the power of 2 times x, right? Because x times x is x to the power of 2. So this means when he tells me that I have 3x plus 2y all to the power of 3, this means that I have 3x plus 2y multiplied by 3x plus 2y multiplied by 3x plus 2y. In this case, I can say that I have 3x plus 2y squared multiplied by 3x plus 2y. And find the result of 3x plus 2y squared, as we know by the special case that we have studied. When I have a binomial squared, this means I'm going to take the first squared, which is going to be 9x squared, and the second squared, which is going to be 4y squared, and the term in the middle is going to be 2 times 3 times 2, which is equal to 12, and for xy it's going to remain as it is. And I'm going to multiply this whole expression with the left expression, which is 3x plus 2y. So again, since 3x plus 2y to the power of 3 means that I have 3x plus 2y times 3x plus 2y times 3x plus 2y, I can combine both of them to give me 3x plus 2y all squared multiplied by 3x plus 2y, and perform the special case here to get a trinomial, and then I multiplied by the remaining binomial, which is 3x plus 2y. So here I'm going to have now 9x squared plus 12xy plus 4y squared, and I'm going to multiply it by 3x plus 2y. So I'm going here to multiply each term by the other term in the other expressions. So now I'm going to multiply 9x squared by 3x squared, and this is equals to 27 x to the power of 3. 9x squared by positive 2y, and this is equal to positive 18 x squared y. And then we are going to multiply positive 12 xy by 3x. This is equal to positive 36 x squared y, because I have here x multiplied by x. And I'm going to multiply 12xy by 2y, and this is going to be equal to 24 xy squared. Y squared because I have here y multiplied by y, and x is alone. The last thing now, I am going to have positive 4y squared multiplied by 3x, and this is equal to positive 12xy squared. Let's erase this first. And then I'm going to have 4y squared multiplied by 2y squared, and this is going to give me positive 8y to the power of 3. Now I'm going to see the like terms and combine them together. We have here 18x squared y plus 36x squared y, and we have positive 24xy squared positive 12xy squared. So for here I have 27x cubed, it's alone, and I have nothing like it, so it's going to be like as it is. And then positive 18x squared y plus 36x squared y, this is equals to positive 54x squared y, and positive 24xy squared plus 12xy squared, this is equals to positive 36xy squared. And I have only one term which has y to the power of 3, so plus 8y to the power of 3. And by now we have finished this part in multiplying binomial, and in the next video we are going to complete the other 2 pages in the binder. I would like to thank you all, Prep 1, and have a nice day.